We'll be starting up with Sergio Grueso, I hope. Sergio is presently a master student and is very soon to join his doctoral research. He's working under Dr. Raquel Bezo Sobera at Cognitive Neuro Lab from Open University of Catalonia. Over to you, Sergio.
Okay. So thank you and welcome to my presentation. Neurocognitive disorders are more and more prevalent in our society as our lifespan increases. And Alzheimer's disease is the most common subtype of dementia. And here you can see the 4 principal characteristics that can be detectable in late stage Alzheimer's disease. But the problem is that it might be too late for the patient to prevent a cognitive decline when all these symptoms appear. And that is why it's important to predict the future outcome of Alzheimer's disease in patients with mild cognitive impairment. And our objective is to perform a systematic review of articles that use machine learning methods to predict a conversion from MCI to AD. The most common ways to visualize these cortical changes are these 2 neuroimaging techniques, and the studies we analyzed use this brain data, like cortical thickness, along with other variables, to train a machine learning classifier and try to predict a future outcome of MCI in patients with MCI. This is the PRISMA workflow we followed for the sample selection, and here you have the inclusion criteria, and we can come back here later, but for now let's just jump to the results section. So almost everyone used ADNI database this is good because ADNI database has been validated for the study of MCI conversion or progression to AD. It also has several years of follow-up from hundreds of MCI patients, and the sample size of this database is increasing every year. Here you can see the neuroimaging techniques selected in each study, and as you can see, the majority of them used magnetic resonance. Also, 3 studies used positron emission tomography, 13 studies used the combination of these 2, and 2 studies used magnetic encephalography. So each study had a cohort of MCI or mild cognitive impairment, but 8 of them also had AD and healthy subjects along with the MCI. 32 of them separated between a stable and progressive MCI, and 4 of them had a healthy subject cohort along with the MCI. Here you can see the mean number of subjects per year, and as you can see, there is a trend of increasing every year, and that might be for the increment of sample size in the ADNI database. The most selected features are cortical thickness and intensity measurements, and that's something we expected, taking into consideration the 2 neuroimaging techniques that were most selected. Other selected features were biological measurements like APOE4 genotype, demographic data like age, and cognitive measurements. The classification method selected, SVM support vector machine, was the most selected classification method. And here you can see 3 types of the Gaussian kernel, which was the most selected kernel for this classification method. That's something we also expected because support vector machine has been proven to be a very good classifier of high-dimensional data. But the tendency of the last 2 years or so is to start using deep learning methods, and the most selected deep learning method was convolutional neural network, which actually was the classifier that correctly classified the most number of subjects. Here you can see a table of comparison of these 2. So the specific search of AD biomarkers is much more abundant than the MCI conversion. And we think it's important not to forget that if we can predict an MCI conversion, we can start now a treatment that can prevent this cognitive decline, and we can allow the patient to live healthier and longer, and also save a lot of resources for the family and public health systems. Also, deep learning is the way it performs better and it's easy to understand the model outcome, meaning that we can see which areas are the actually ones that help correctly classify subjects. And the most important regions of the brain for Emcee classification are actually the ones that has been extensively validated by the literature, meaning that the information that the models provide is actually useful. Here you can see the brain areas that were the most important for this binary classification. And it still needs a lot of work because it's far from perfect, but it can be useful for helping clinicians for assessing clinical professionals. And I think it's a really interesting line of research. So thank you very much for your attention. And before the questions, I just want to say that here you have extra discussion points like the risk of bias analysis I performed, and also that I have all the studies sorted by neuroimaging technique here. But for now, let's go back to the slide about the discussion points I think are more important of my research. Okay. I don't know if there are any questions.
This is an interactive session, so I would appreciate if someone has any questions, we can take up the questions in between as well. Please drop in your questions. I think we do have one from Eva. Could you describe the key brain areas a bit more? Did you expect these findings anything unusual? Thanks, Eva, for the question. Please, Sergio.
Oh, yes, the brain areas. Here. So not really. Basically, the brain areas are the classic brain areas we also always talk about when we talk about Alzheimer, like hippocampal regions or temporal regions or frontal regions. And here you can see the most important ones in this binary classification. For example, AD versus healthy controls or MCI conversive versus stable. And yeah.
Thanks, Sergio. There is another question by Marta Russo. Can you describe a bit more the features that were used in the classifiers?
Yes. So the features, normally they were other cortical thickness or intensity measurements. And this cortical thickness, for example, was from 90 or more regions of interest. Something I didn't do in my investigation was perform an analysis about the feature selection because I didn't have time. But basically, the matrix of data was out of subjects and out of regions of interest, and they extract the cortical thickness or intensity measurements, and also biological features like APOE for genotype I said, or demographic data like age, gender, years of study, and also cognitive measurements like mini mental state exam or other kind of tests or neuropsychological tests. So those were basically the features.
Thanks, Sergio. Any other questions that we have from the audience? Anyone from the panelists would like to ask a question?
Yeah, I'll ask one. So I think you may have gone over this, but it's quite quick. So you had quite a few different MCI groups, and I'm wondering how you defined them initially.
Okay, so ADNI database has follow-up years, and MCI subjects were evaluated several times along these years, and then if the MCI subject converted to AD in, for example, 5 years or 3 years, depending on the follow-up, then it's considered a conversive MCI, and if not, it's a stable MCI, meaning that the cognitive decline didn't occur.
Okay, thank you.
Thanks, everyone. So that's very nice talk, Sergio.